Hey, thank you so much for the kind introduction. So yeah, so I'm performing as an artist under the moniker Herr Shield. And so I mostly perform with like analog hardware and modular synthesizers and things like that. And yeah, you can find some of my music on that website. So like when the pandemic started, I really got into the live performing thing. So I was in a music collective and we did regular streams, and I was performing with modular synths and like a pretty big setup. And of course the pandemic happened, so the setup was growing and growing. And so at some point I had the problem that like all of the gear that I had accumulated, like I still needed to sequence it. So I had like a bunch of analog polysynths, and like I had this modular synth that was growing. And like in the modular synth, I really learned to appreciate like how awesome these generative sequencing techniques are. Like for example, like if you would take an LFO and you feed it through a pitch quantizer, like you get an instant melody out of it, and then you start modulating the LFO, and like it gets really interesting. And so yeah, so I had all of this gear, and like I was just frustrated by buying more and more sequencers, and none of them did what I wanted. And like once the pandemic ended, I also had the opposite problem where I wanted to perform live in a club, and I had this gigantic modular that I had all of these cool tricks that I could do, but I couldn't bring that into a club. So my setup also needed to be able to scale to a very small setup. And yeah, so of course I explored this idea of, well, how do I use maybe a computer? Like a computer is very powerful, but yeah, I never managed to get like a stable setup with a DAW. Like there was always too much MIDI jitter, things were just not working, and you also didn't have the nice workflow as I was used to it. And so in the end, yeah, I just came to the conclusion, like I can write software, like how hard can it really be to write like my own perfect little sequencer. So I'll be talking about trackers a lot, so let's maybe briefly talk about what a tracker is. So on these pictures here, so on the bottom left, you can see like the very first tracker that ever existed. So that was on the Amiga, and then in the middle, you can see also a very famous tracker, so that's Octamed. And so that tracker, for example, was like really instrumental to shape like entire musical genres like jungle. And then on the right, you can see an album cover of like a famous artist. So he was also famously using lots of trackers in his compositions. So that's Aphex Twin. And yeah, if you think about a tracker, then it's a little bit of a different concept than composing music in a DAW. So in the DAW, you write up your melodies and chord progressions in the piano roll, and like that one goes from left to right. And in the tracker, instead, you write your music from top to bottom. But essentially, when you look at the tracker a little bit, then it starts to look a little bit more like programming than composing. So essentially, you have like lines of code that make music, and that get scheduled over time by the sequencer for you. And if you look at these pictures here, then you can also see that there are like a few notes, but then there are also all these weird numbers next to it. And so these are like special fields in the tracker that allow you to do like effect commands. And so with that, you can control both the sound engines as well as the sequencer. And so it's really like a programming environment for music if you think about it long enough. And so that was super inspiring for me, and that's why I wanted to work that way. All right, so enough talking. So I'll just briefly demo the tracker for you. So this is the main screen of the tracker. So the tracker, it has 16 tracks. So from left to right, and then what you see here, that's like the pattern overview. So all of these numbers are different patterns, and then for each track you decide what kind of track is it. For example, this track here, it has like a polyphonic sampler engine that can also be a synthesizer. So I'll just create a pattern here, and I select the sound here, so that one is just 0, 0, and then I can place a note here. I can place another note here. Let's maybe go for this, and so I also like, so this will be executed top to bottom, and like I also need the notes that they should stop at some point. So I'll just stop that here and here. And so now I press play, we can see the playback cursor, and so we can hear our first little melody. All right, that's maybe not super exciting yet, but so as I mentioned, like in the tracker, we have these command columns. So these columns here on the right are in Shield Tracker what the command columns are. So I can open it, and you can see there's like a bunch of commands. Don't read all of that. But the very first one, that one is called chord. And so that one allows you to do 80s style chord memory. So I tell it which note column I want to apply it to, and also what chord I want to apply. And then I have like a chord definition here. So that's the one that's going to be used. And so I just defined the chord before. It doesn't matter what exactly it is, just some minor chord. And so now we already have like something that sounds way nicer. Then next, here this track, it's like a breakbeat track. So that's specifically made to program breakbeats. I created yet another pattern. I'll just make it shorter to 16 steps. And so now I can just select the aim and break here. So now I can do breakbeat slicing here just built in. And I can layer the second breakbeat on top if I want. I don't know which one to pick. And then to make it jungle, we also need some form of a bass line. So I can turn this track into a monophonic sampler track. I'll create yet another pattern. I'll make it 16 steps. I'll place some notes. I don't really know what I'm doing. Maybe here. And so now I also need to load a sample. And so I have this built-in file browser. 808 kick drum, and let's pitch it a little bit. Maybe it's a bit too low for the speakers here, but we can just pitch it up. And yeah, so from 0 to jungle in like 1 or 2 minutes. And yeah, so you can see like it's a pretty quick workflow, like once you know how to use the tracker. Then I also mentioned that I'm really excited about these like generative sequencing approaches and to bring this modular synthesizer workflow in here. And so I have another demo here, and I'll just start playing it. And so in particular, I want to focus on this pattern here. And so if you look at the sequence of notes, then you can see that every time that the pattern loops, like that the notes are changing. And so what is happening here in this pattern is that at the first playthrough, a random melody is generated. And then with each playthrough, one iteration of a sorting algorithm is performed. So if you look closely at the notes, you can see that the higher pitches, like they shift to the bottom eventually. And at some point, yeah, now we have a new melody because it was fully sorted, and so we have like, yeah, a fully new sequence, and we can let this run forever and it will subtly change and it's fine in the background. And so the way that I can do that is by writing like custom commands in this command column. So it has like this built-in programming language that is somewhat assembly inspired, and here simply a little loop, and so that one will generate random notes, store them in the pattern, and then here's the sorting program. That one performs bubble sort and counts how many swaps have been performed. So it just goes over consecutive notes, compares them, does it need to swap them, and that's pretty much it. And yeah, so it gets like very quickly very complex, but it's not crazy hard to do. All right, time is an issue, so I'll just move on. So yeah, I want to briefly also talk about the development history of the tracker. So when I started working on it, like I just started with like a bare bones setup. So I only had like essentially an OpenGL context in like a window open, and I used Jack Audio on Linux. And I would highly recommend to actually start like that because it's super easy and super quick to get going. So I remember like when I worked on it, like I had like the first MIDI notes coming out on day 1. And like after only 1 week, like I already recorded the first jam with like an external hardware synthesizer and put it on YouTube. And so I'm not like a super rock star coder, so it's actually pretty simple if you just simplify the problem a little bit. So essentially what I had built was just like a text mode rendering thing, and so I just wrote text in a few lines, and that were my notes, and I had a cursor that I could move around and change it. So that's not very complicated to program, but it's very powerful and very quick. And yeah, so it, of course, escalated like everything does. And so after 1 month, I was in the situation that you can see on the picture at the bottom. So my full studio was sequenced by that, so CV-gate sequencing running. And so the projector was hooked up to like some embedded Linux device and things like that. And after 6 months, I performed live with that. So it had completely replaced like my existing sequencer setup and was the centerpiece of that performance. Yeah, one of the things that also made development really fast is, yeah, first of all, like the fastest thing to do something is not to do it. So for example, I avoided implementing saving and loading of projects. I just kept some structs in virtual memory, in shared memory around. And like when the layout changed, I started from scratch. It was fine. And so that's what saved me for the first 2-3 months. And yeah, I was using lots of code, hot reloading. Sorry, that's a screensaver. And yeah, so by that, I could just edit the program while it was running, which makes it super quick to iterate because you see like, oh shit, I formatted the node wrong. So you just fix the code while it's running. And in the best case, you even have music playing that sounds nice while you're developing. I also might have come up with a little bit of an unusual architecture. So like the longest time before developing that is like I was thinking about how do you actually synchronize like your UI code with the audio rendering. Like you need to change parameters and get them to the audio thread somehow. And at some point I realized like, well, I'll just not do that. And instead, I just put the input handling into the audio thread. So at the beginning of each audio block, I just process the input events. And like since the UI is not very complicated, it actually takes like no time at all. And so all of the synchronization issues suddenly are solved. And like I don't have to think about it. So you can see like the pseudocode here. So I just like it's the most naive way. Like the entire tracker is like written in the most naive way possible. So I just loop over all audio samples, I update my clocks, and if the sequencer needs to be executed, I do that, and otherwise I just render the audio. And the graphics thread, that poor little guy, it just has to deal with whatever it finds in memory and just displays that, and sometimes it might be corrupt or not, but it just deals with it and hopefully doesn't crash, which it never has done for me. So also the tracker is written like in a very brute force manner, so I don't keep track of things that change or anything. If something needs to be computed, I just recompute everything from scratch. And so I rather do everything brute force and do it quick. So things are implemented without virtual function calls. I use SIMD processing where possible. And yeah, like by not doing the state management myself, like things get much faster, like development time-wise. And nowadays, CPUs are so fast that it's not a problem. Also, like the tracker, like it uses a lot of code generation. So at this point, the project sits at around like 45,000 lines of code. And when I compile it, it also generates around 40,000 lines of code. And so when I started working on the tracker, I was like trying to be a good citizen and just use C++ as intended with lots of templates, macros, and like emulating some form of templating system by putting defines and then including headers, but that was super painful. You all know like how stupidly hard it is to turn an enum into a string. And so I escalated, I put Python into the mix, and like, so I defined my enums in Python, generated all of the source code so that I could edit it in the UI. But still, the problem, like it kept getting bigger and bigger. So like the compile times were really horrible at some points. I had like 1 minute 30 for a single C++ file because of the templates. And so I escalated, of course, even further and developed my own little definition language for user interfaces. And so I replaced a lot of the template stuff, and now the compile times are back down to like less than 10 seconds. And so this sounds like a lot of effort, but so that's one of the things that I learned working on this project, that doing things yourself is, first of all, super fun. Second of all, you can be very quick if you just build what you need and like forget all of these complicated details. And I'd rather spend the time writing my own parser than learning how to use like these terrible parsing frameworks. Here you can see like a quick demo of what this UI language looks like that I came up with. So here we have the UI. There's like some string editor and sliders. And yeah, at the bottom you can see like how you can define the UI. So you can write just an enum in the language, and you can use it in, like, dialog is effectively what used to be a struct, and then so this language just generates for you all of the code to do serialization, to do the input handling, and to do the rendering. So it becomes really convenient to develop this again. And I guess you might have noticed by now that I also decided to just do the slides in this dialog definition language. So yeah, so that's this little project. Check it out on the website. So it's currently just available for free. So it runs primarily on the Steam Deck or on Linux. I have some experimental macOS port. For that, you'll have to join my Discord, so I post it there occasionally. And yeah, I want to thank you all for the attention. And yeah, enjoy the pizza.